Okay, let us recap. I can have any curve. Alright, if I want to find a tangent to a particular point, let's say this is the tangent to a particular point. In Emath, you have done it before. Alright, you will draw a line. Okay, such a balance. Agree? This is the line that is tangent to the curve at this point. But how about normal? What is the first thing that comes to your mind? When they are perpendicular or 90 degrees to one another. So at this particular point, this is the normal. That is in Emath. You need to draw. But in Emath, I already told you at the start of this chapter, we don't have to do that. Why? Yes? Why? Hello? We just apply differentiation good enough already. Remember? First derivative, differentiate with respect to y, and when you want to find the gradient of the tangent, okay, you can all apply differentiation itself. Alright? So, whenever you need to find tangent, just apply differentiation. And the one thing you need to know is the gradient of the tangent, the product of the gradient of the tangent and the gradient of the normal will give us -1. This means that so long I have one of the gradient, I can find the other one by taking the negative reciprocal. Agree? Very good. We are done already. We just need to apply all these things into a word problem. That's it. Okay? Now, please turn to page 354. Practice now 10. Trust me, it's not too difficult. Alright, Josiah, are you with me? Are you sure?
Yeah.
You're not praying to God or something? Yeah. Sure? Okay, let us take a look at question 2. Page 354, practice now 10. Josiah, can you read the question for us?
Practice now 10.
I cannot hear you, I'm not your girlfriend.
Find the equation of the tangent and the normal to the curve y equals to 2x cubed minus 9x squared plus 12x plus 7 at the point where x equals to 1 half.
Okay, so the question is very straightforward. Find the equation of the tangent. Remember, the first thing that comes to your mind when you see the word tangent, what do you do?
Draw line.
No need to draw line. Draw line is
Gradient.
just associate with gradient. And we associate gradient with dy dx, right? Very quickly, think of, can you tell me how to differentiate this one?
6x to power minus 18x plus
1 mark. Straight away. This is easy differentiation. Well, I told you in a word problem, a differentiation cannot be too difficult. Now, this dy dx, I must put it in red again. It's meant for the tangent. Don't confuse it. Remember, whenever you do your first derivative, it's always for the tangent. At which point? At the point x is equal to 1.5. Find the gradient of tangent. How can we do this? Substitute 1.5 inside the expression over here. Okay? So now, Jinan, can you substitute inside? Help me press the calculator. And everyone, please take out a calculator and don't wait for the answer also. You need to practice calculating. Negative 4.5. Negative 1.5. Okay, I'm going to do Emath now. I want to find the equation of the tangent. I have obtained the normal. So what do? y is equal to the gradient x plus c. Y equal mx plus c. Agree? You need to use a point to find c. But this literally no point given. There's only x equal 1.5. How do I know what is y? Not the tangent. Sub x is equal 1.5 into the orbit. Have we seen this trick before? A couple of times already. No, we have done it before. If you have x coordinate, you don't have y coordinate, substitute back into the original one. So in this case, I don't want to write another step. At x is equal to 1.5, I write below, or you can write comma beside also can. Just write directly below, because all these are the same working. I don't keep writing and writing. I get confused. So at the x coordinate 1.5, substitute into the original equation as well. Steven, can you press 1.5 inside this one? And do you have a sharp calculator? Also not that. Yeah, then use sharp. So use sub-0. Sharp is sharper. 11 point. Double check. Just bracket square, got full division. 11.5. So I'm going to use this answer. Use the x coordinate, the y coordinate, substitute inside here. What's the final answer here? 1.5, 1.5, 2.25, 13.75. Okay, I would like to caution everybody. Guess what I want to caution you? No, not a negative. If this is in decimal, please have this answer in decimal. If this is in fraction, please write this as a fraction. Okay? Either one, there's a mixture of fraction and decimal within the same answer. So you need to choose either one of these. And this thing, you must put a bracket. Equation of normal. Why do I want to do that? Why do I want to do that? Because we are not done yet. They ask you to find both the equation of the tangent as well as the, what normal? The first one is tangent. We are not done. We still need to find the equation of the normal. Am I right to say that? This one? Doesn't matter. This is working. Working, anything you want to do, I will fault you. Improper fraction, I won't fault you. So long the final answer must be precise. Okay? Now, sorry, no more space. I'll continue from here. How to find equation of the normal? Which one? Gradient, what about the gradient? We have the gradient of the tangent already, but the relationship, how do you form that relationship? Okay, good. So the gradient of the tangent is negative 1.5 times gradient of normal. This will give us negative 1. Am I right? So what do we do? Divide everything throughout by negative 1.5. I think you should get 2/3. Same thing, go back to your y equal to mx plus c. Which point do we substitute inside again? Same point. Don't go through the hassle of finding everything again. Huh? Someone needs to press the calculator for me again. 11.5 minus 2/3 times 1.5. 10.5. Hello? How many marks will this question be awarded? 5. 3 marks. And nobody wants to do this question already. It will be 3 marks if I never ask you to do this one. This will be 3 marks. You are correct. But if I still ask you to find equation of the normal, this is an additional 2 marks. Okay? Equation of any line is always 2 marks. But then if, why Mr. Liu this one for 3 marks? Differentiation. Okay? The differentiation is worth 1 mark by itself. 可以吗? Okay? So good. Please try question 3 yourself. Follow the same style.